Hello students, it's your professor here. I just want to go over a few things that I will be testing you on for quiz 2. So from module 4, when we're talking about insights, we left off at the lecture talking about the CRISP model. The CRISP model stands for Cross-Industry Process for Data Mining. It is a widely used framework that outlines the steps involved in a typical data mining machine learning project. It provides us with a structured approach to guide organizations and data scientists through the different stages. The first stage is the business understanding. This is where we define the objectives of the project, identify key factors that can contribute to the success of the project, and establish a clear understanding of the problem. Next, we have our data understanding. This is where we gather and explore relevant data for the project. And look at the data quality. We may also include looking at some exploratory data analysis to help us gain some insights into the data. And then we would do some data preparation. This is obviously cleaning the data, reprocessing it, transforming it for analysis, handling missing values. What do we do with outliers or numbers that don't look like they belong? Preparing the data for modeling. And the next stage is modeling, where we select and apply the appropriate modeling techniques based on the project's objectives. This may involve some type of machine learning algorithms, statistical methods, or other modeling approaches. We've talked about some of them, right? K-means clustering or regression analysis, or any of the different techniques that I've talked to in passing in this course. Then we evaluate the performance of our model. This typically includes or basically this phase is when you partition your data, you split it into two sections, what we call a testing data set, and then we also have a training data set where we validate the model and use it for predictive analysis. And then finally we deploy our model into the operational environment that we ask it to do. What it will make it part of our production environment for our business. This includes putting the model into production and monitoring its performance and making the necessary adjustments to the model and making sure it aligns with the business objectives and contributes value to the business. So the next slide here just kind of walks us through some of what I just talked about. So have a peek at the different phases or stages of the CRISP model. You can be tested on that, or could be tested on that. Next, if we talk about data mining, again, it is used as part of the decision-making process of many firms. It can also be used to create dashboards and reports, and also part of the automated decision-making process of companies. Again, we've talked about descriptive data mining. such as clustering, when we're looking for patterns or in the data to cluster or group different types of customers together so that we can offer them different types of products. Diagnostic, this is in the creating of what we call decision trees or decision tables that help us make standardized decisions on the fly using decision trees. And then finally, predictive data mining. This is where we use the classification and we determine where, let's say, new customers, which cluster we should put them in. Now, some common mistakes that companies often make when deploying data mining is first of all, the expectations are too high. They expect some earth-shattering, the next greatest thing since sliced bread to happen to their company. Or sometimes they put the tool in the hands of the people that don't know how to utilize it properly. So you need to put it in the hands of the right people that can actually use those insights and make actionable decisions. Sometimes we do not show people how to use the tool properly, so maybe training is an issue. Or sometimes we look for quick wins rather than planning for the long term. And sometimes the data roles and governance are not adequately defined, or the organization fails to demonstrate value from data mining. Okay, let's keep going here. Next, I want to talk about OLAP, Online Analytical Processing. This is the back-end technology that is in a lot of software like Tableau and Excel that enables us to query data very quickly and in a simplified manner. OLAP stores the data in a cube. Thus, I have that image of the Rubik's Cube, and you can ask me later what a Rubik's Cube is. And so it allows us to store our data in rows and columns in 3 dimensions, actually, and allows for quick retrieval. And it's an interactive solution. And again, it's supported by Excel, supported by Microsoft Access, all these other applications can support OLAP. And it's easy to build Power Pivot solutions in Excel using OLAP. OLAP recognizes the different measures or numbers and dimensions, categories, and allows the user to slice the different categories. Categories could be, sales data that we want to view by region, right? By different region. Like in Canada, we might want to, separate Ontario from the other provinces because Ontario is the largest province and might have a lot of sales. Or we might want to group the maritime provinces because they're small together and say we want to look at sales by the maritime or eastern provinces, or look at sales by a specific product or a specific customer. So we can slice our data into different multi-dimensional views. For example, we can look at data by, you look at units and prices and sales by size, right? Small, medium, large, Excel, or by region and by year. Okay, so we have that ability to slice our data any which way we want to using OLAP technology. Here's another example where we can look at data, by region, by size for different years. And this is a pivot table that is built using OLAP technology. So OLAP also allows us to start at a high level and drill down to item level data, or drill up, aggregate, go the other way, take item level information and then sum up different items and aggregate them. And so this is kind of, when we're looking at data in two or more dimensions, it's called a dice. So the tool allows us to slice and dice. Drilling up or drilling down, digging deeper into item level detail. Let's say we start at summary level and we can drill down to item level detail, or start at item level detail and summarize products that are of a similar type or characteristic, and drill up. It also allows us to create calculated fields on the fly, and we don't need to constantly revise or recreate calculated fields. Once we calculate the field or create the equation that does the calculation, it can drill up or drill down. It moves with the data. And so here's an active calculation. Current year sales minus last year's sales divided by last year's sales times 100. This is a percentage, and you can drill down into the data, and the percentage growth rate will be reflected in the drilled down dimension. So as part of your Tableau training on with Kurt Fry and LinkedIn, see if you can create calculated fields. Okay? If Kurt hasn't talked about it yet, use YouTube. See if you can find how you can create a calculated field. When you start working on your projects in a few weeks, I want you to generate and create calculated fields or computed fields like growth rates. Okay, those types of dynamic variables are very important, and that's what sales managers want to look at. Sure, some of the static information that you provide them is good, but managers want to understand, did we change? What was the change from the this period versus last period? It could be a month, it could be a week, it could be a year. How did we do comparing ourselves to the last time frame? Okay? So, OLAP also allows us to mix and match dimensions. It is easy to move around in OLAP. Like, you can transpose annual data from having it be in a row to a column. Okay? Things of that nature. So there's my first video. Okay, I'm going to make another quick video and shortly, and I will post that one as well on the topic of BI user groups and looking at what kind of people want to use BI and the different types of users. Okay.